Ok, gente? Então eu vou mostrar para vocês agora, nessa rotação, quando que eu estou gerando aqui, nesse geradorzinho, valeu? Vamos nessa. Pronto, gente, então aí está em 0. Vou colocar aqui, ó, o terminal. Estamos gerando aí 15 ponto alguma coisa. Tá vendo aí? Esse motorzinho aqui está em baixa rotação, como vocês podem ver. Se eu quiser aumentar a potência dele aqui, é só mudar aqui as polias. Mas por enquanto, dá para ver o sistema montado. O mais importante aqui é a montagem do sistema e ver também a turbina Pelto funcionando. Ok, gente? A tensão aqui não é tão importante quanto o sistema funcionando. O fio está saindo do geradorzinho aqui, como vocês podem ver, ó. Aí agora nós temos aqui uma tensão de 15 ponto alguma coisa, quase 16 volts, ok? Podem ver que a rotação do motor está bem pequena porque eu coloquei aqui, ó, um sistema de tração de força. Aqui é um redutor, um sistema de tração de força. Para eu ter mais velocidade no motor, aqui no gerador, eu vou ter que colocar mais algumas polias aqui para poder ir aumentando a rotação. Aí eu vou ter que fazer um multiplicador com essa força que eu tô tendo aqui, ó. E aqui eu tenho força bastante, ó. Ó, leva até minha mão, ó. Aqui eu tenho rotação e aqui eu tenho força. Então, pessoal, quem gostou do vídeo, não se esqueça de se inscrever no canal, deixar um like e
In 2006, fluid-driven electricity generator, a revolutionary device that generates free energy using simple mechanical principles. It operates by directing a jet of water at a flywheel, which spins an electrical alternator, creating electricity to power both the pump and additional external devices. Despite the elegance of its design, this invention never gained the recognition it deserved. Even more troubling, it has been conspicuously absent from educational curricula or mainstream energy discussions. The device is rooted in basic physics, principles that we learn in high school: leverage, kinetic energy, and Newton's laws. Hardy's generator uses a small water jet to accelerate a flywheel through the principle of leverage, magnifying a small force to overcome the reverse electromotive force in the AC generator. As the flywheel gains speed, its kinetic energy increases, allowing it to power the generator without overloading the system. By incorporating an auxiliary flywheel, the design ensures stability, preventing the system from stalling due to momentary overloads. The science behind the generator. At the core of this design is the principle of kinetic energy, specifically how a rotating flywheel can store and release energy. Using the formula K equals half.I omega 2. Hardy showed that even a modest amount of force applied to the flywheel can generate a significant amount of kinetic energy. This energy powers the alternator, which generates electricity, all while using a minimal input of water force. The flywheel's interaction with the water nozzle demonstrates the principle of leverage in a fluid system. The small water jet gradually accelerates the flywheel to match the water's velocity. The device cleverly uses an auxiliary flywheel to balance the system and prevent sudden stops, ensuring continuous operation. By carefully balancing these forces, Hardy's invention achieves overunity, producing more energy than it consumes. Why is this not taught in schools? Despite its groundbreaking potential, this free energy generator has not been incorporated into educational programs. Instead, today's education system emphasizes rigid formulas and rote memorization, focusing on multiple choice tests rather than fostering creative experimentation. Critical principles such as leverage, kinetic energy, and free energy applications remain marginalized or excluded altogether from mainstream physics courses. This oversight leads to a troubling question: why are free energy technologies like Hardy's generator not more widely known or taught? Conspiracy theorists argue that this suppression is not accidental but a deliberate attempt to maintain control over energy production. Traditional fuel-based systems remain lucrative, and disruptive technologies that threaten to upend established industries are ignored or dismissed. It is argued that we live in a matrix of controlled education and information, where innovative solutions like Hardy's are buried to protect the economic interests of fossil fuels and traditional energy systems. A conspiracy of suppression? The suppression of Hardy's fluid-driven electricity generator fits into a broader pattern of how free energy technologies are sidelined. Even though the device is based on well-known physical principles, it is not taught in universities, researched extensively, or implemented in society. The notion that the global energy system is built on fuel consumption is powerful, and anything that challenges that model is seen as a threat. For decades, scientists, inventors, and researchers have put forth ideas and devices that could change how we produce and consume energy, only to see them dismissed, ridiculed, or ignored. The education system, often viewed as a gateway to knowledge and progress, may actually be part of this conspiracy of suppression. By focusing on formulas and theoretical problems, students are discouraged from thinking critically about real-world applications, especially those that challenge the status quo. Free energy principles are labeled as pseudoscience, and innovators like Hardy are sidelined, their inventions forgotten.
Okay, I have a turbo pump here, and I'm going to do a test run and show you how what I have for a pump here, because it's the pump and the generator. It's a turbo pump. It's about 165 gallons per minute. And I just wanted to show you, this is a 20-gallon drum, water, filled it up. I just want to show you how, what kind of pressure that I needed for the old generator. So I'm giving you a little test run here. Alrighty, nobody's filming, so the camera's just hanging out there. So, okay, put this in here. Gotta plug myself in over here. I got gloves on, I got my boots. Okay. I can get zapped here, but okay, here it goes. All right. Okay. All right. If you can see that. Oh yeah. There it goes. That's the pump I'm using. 165 gallons per minute. You just seen about 20 gallons go through, what, 5, 6, 7, 8 seconds, I don't know. Anyways, and I'm going to go in there and we're going to set up the pump into the generator and the machine, and we'll take another step after that. Okay, if everything's fine, we're recording, then I put the pump inside the chamber here. It's rigged up so it will hit against this water wheel, the paddles, whatever. Against the big flywheel I have 18-inch. I've already gone through plenty of these and down to a 4-inch that I've gone from 4 to 8. So anyways, we got this lined up so it hits against here. It's going to give the electricity we need, and I'm going to show you how the theory is wrong, and this will run on its own. We've already tested it 3 or 4 times. It's worked. This is the 3rd try today. Let's hope this one works, where I unplug it in here that quick, and we can just continue on here. So I'm going to do a quickie from here to here, here from here to here. Okay, it should take only a second. If I can do it in a second or two, she'll stay going. With the momentum that gives from the pump, she'll draw right off there. Okay, so, all right, here we go. We're going to try it again. This is the 3rd time. Okay, here goes. Okay, let me empty the bucket here. I'm leaking all over the place. That's why I got rubbers on. I got rubber underneath. I could still get fried, but okay. Let me make sure this is ready here, from here to here, here to here, here to here. Okay. All right, here goes. Let me get over here just to move this along. Okay. All right, it's going pretty good. A little faster. Okay, that's the revolutions I should need right there. All right, okay. All right. See if it works. Oh, if I don't get trapped. Okay, she's going. All right, that's it. All right. Keep it going. All right, now that is drawing off its own power right now. All right, there you go. I mean, there's the outside current right there. It's going on this. There's the power from the house out of here. It's running on its own. All right, the pump is drawing up the generator, forcing that wheel to turn it. There we go. Check this out. I got nothing here to stop this. This machine is running on its own right now. All I have to do now is to shut this off, unplug the plug, and that's it. There it goes. Yeah, I'm just showing you the machine. It's drained out, water's taken out. There's the pump with the paddle, water wheel. Goes down the shaft onto a belt drive, and the belt goes down to the smaller belt drive that hooks to the generator. And I went through quite a few different sizes to get what I needed. So, and the generator itself was rebuilt. I had to send it out to a friend of mine that works on generators, and he did the coil all over, drilled a couple dozen holes into it, and plus he changed the bearings in that, put some free-falling bearings in the generator, added a couple of capacitors, and came up with the what we needed. So basically it's a simple thing. The pressure I needed for the pump, against the paddle, and down to the shaft, down to the other one, and to the generator. So basically that's it. And then the electricity here, and that's about it. So that's the whole thing together here.